I would like to welcome you all in the lecture series of power electronics. I have already discussed the topic current source inverter with the help of waveforms, equations, etc. You can go through that particular topic before watching this topic, which I am going to compose this video. Here, I'm mainly focusing on how to develop current source inverter with the help of MATLAB. Okay, so in this session, you are going to study the MATLAB code for current source inverter. You need to follow the given steps. First one is the input. You are supposed to give the input details, such as you are mainly focusing on the input parameters. One is current source, okay, IDC, and also like you have to mention about the expected output frequency. So these are the input you are supposed to make out. Now, another important thing is switching function. So you have to decide two complementary switches S1 and S2 respectively, which will operate alternate to the current flow through the load. And you need to talk about the square function which generate the switching signals. Also like output current. So output current waveforms is determined by the switching of S1 and S2. Okay, you mentioned that both the switches are never operate at a time. The load current alternate the polarity but maintain the constant amplitude. So these are the three important steps you are supposed to talk about the current source inverter. Now, I'll be developing the code according to the algorithm, whatever we have designed, whatever we have developed. Now, I'll take you to the MATLAB code. So you can open the MATLAB and you can start typing this particular code. If you need the code, I'm going to share this specified code. So as you can see, the first of all, I have defined the parameters, IDC, frequency, time period, and total time vector for the two cycle. Complete cycle I'll be taking care. So these are the input parameters. Now switching function I need to define. So you can use the formula S1 is equal to square. Square is a function which is already available in the library. 2 pi ft, comma 50. So switching function I have designed. Remember S2 and S1 are opposite, anti-parallel. Okay, complementary each other. So S2 is nothing but minus of S1. Output current can be written by I output is equal to IDC into S1. IDC star S1. Star is an operator. So output current is in the same SI waveform is also decided. I need to have the waveform, so I'll be using the figure. Later, I would like to go for like a plotting. So subplot I have used, then plotting like initialization like once I have used, then title of these waveforms. The labeling is done systematically. Later on, I need to have a graphical appearance, so grid is already on. Then switching signal will be generated in this fashion. So I need to plot the switching signals accordingly. So I need to hold on, then plot S2G line width, all the things I need to take care. Okay, then output current waveforms will be plotted. At last, you can see the output current, right? So displaying the like a subtitle like a current source inverter CSI simulation. That will be the title of the like a subplot. So these are the important steps which you need to consider for the development of the code for CSA, current source inverter. So if you have any questions related to this topic, I request you to ask with me. Like you can use the comment box. Thank you very much for watching this video. I wish you happy learning. Have a great day, and it may help for your future placements and also focus on this particular coding development. Very important. Have a great day. Happy learning.